class, welcome back to my video, and this one we're going to talk about hypothesis testing for the ratio of two population variances. So the parameter here is still about sigma square, but the one that involves two population variances, which means that if you have a claim or a hypothesis concerning two population variances, the variances of two different populations, okay, if you want to investigate about the variances of these two populations, then this is the hypothesis testing that you should use lah. Alright, which is F test. Okay, so the type of test that you will use for two population variances is F test. So it's not Z test, not T test, not chi-square test, but F test. And the formula is very simple. In fact, it is the most simplified formula. This is a very simple formula. Sample variance from population 1 divided by sample variance from population 2. That's it. Okay. Sample variance 1 divided by sample variance 2. That is the formula to calculate your test statistics for this hypothesis testing concerning ratio of two population variances. Now, of course, there are three types of tail tests, two tail, right tail, and also left tail test. And your rejection regions is also similar to the previous subtopics. And the critical value for all the types of tail tests are always positive, okay, which means that even for the left hand side, it is also positive. It will not be negative like the one you established in a Z critical and T critical anti-critical value. So always positive. So you if you have a two tail test, hypothesis testing for ratio of 2 sigma square, okay, you need to find two critical value, one on the left hand side and one for the right hand side. So for the left hand side, it is f1 minus alpha divided by 2 nu1 nu2. For the right hand side, it is f alpha divided by 2 nu1 nu2. Okay, that is for the two tail test. For right tail test, the right hand side critical value, okay, there's only one critical value on the right hand side. It is f alpha nu1 nu2. And for the left tail test, okay, rejection region is on the left hand side. The critical value is f1 minus alpha nu1 nu2. f1 minus alpha nu1 nu2, which is also equivalent to 1 divided by f alpha nu2 nu1. Okay, I'm sure that you are familiar with this from chapter 2. Okay, you are familiar on how to find the critical value from the F distribution table. Now, jom kita terus pergi to the first example. Okay, a manager in a large computer operation company wants to study the use of computer from two departments within the company. The departments are the human resource department and the research department. The usage of times in seconds for each job is recorded as follows. So they have 1, 2, 3, 4, 5 data for the human resource and 6 data for the research. So maybe they only recorded the time for each job from 5 people in human resource and 6 people from research. Okay, so that's what they do, and this is the data collected. Now, question A, is there any difference in the variability of usage times of computer for each job from the two departments at alpha 0.05? So this is the claim class. This is what you need to test. You need to see whether is there any difference in the variability class. You see here, there is no population mean mentioned, there is no standard deviation curve. So this is the only keyword, okay, variability. This keyword is what tells you this is about standard deviation or variance. Okay, variability mesti variance or standard deviation. Okay, but for hypothesis testing, we're going to focus on variance lah. So, is there any difference in the variability for the two department? Which means, does the sigma square human resource different to sigma square of research? Okay, there are two groups kan, human resource group and also the research groups. So now you need to test whether or not there's any difference in the variability of sigma square for human resource and sigma square for research department. Okay, so ni lah dia. Difference mean not equal kan. So sigma square 1 not equals to sigma square 2, in which sigma square 1 here, the notation 1 here represent human resource, and notation 2 here represent research department. So kat sini kita faham lah. Okay, variance human resource different from variance research department. This is your claim. Okay, hypothesis testing to test whether this is true or whether this is to be rejected. Oh my god, there's a mistake in this slide here. I just realized that. You see here, this is 1. It's not H not H1 H not H1. MashaAllah. Okay, so next step, you need to calculate the test statistics value. Yep, from the given data. Allahu Akbar. Mana? Okay, for the given data, you need to find the sample variance using the statistical function in your calculator. Okay, find the sample variance from your calculator. Right, so next, you pun, bukan kat sini. Okay, so you calculate the F-test, very simple. Sample variance human resource divided by sample variance research department, 1.0808. Alright. Oh yeah, class. I think you may notice that for two population variance, I don't even transfer this parameter to the left hand side. So yeah, you don't need to do that. So that is step number 2. Step number 3, we need to establish the rejection region. So this is a two-tailed test, right? Kan? Two-tailed test. So let's recall what is the left tail test formula for this two-tailed test and the right hand side, left hand side and right hand side. So let's go to the right hand side first. It is F alpha divided by 2 nu 1 nu 2. Nu here is n minus 1 lah. Okay. So for the right hand side, alpha divided by 2, alpha here is 0.05. So divided by 2, it will be 0.025. Okay. Nu 1 is the first sample. So 5 minus 1 is 4. Nu 2 is 6 minus 1, 5. So you need to find this from your table. Okay. Go to the page that has alpha 0.025. And then at the top row, find number 4. At the side column, find number 5. You should be able to see 7.3879. Okay. It will match you to 7.3879. So that is your right hand side critical value. So for the left hand side, it is 1 minus alpha divided by 2 nu 1 nu 2, which is also equivalent to 1 divided by F alpha nu 2 nu 1. So F alpha is F 0.025, nu 2 nu 1, 5, 4. Okay, so find this in your table. Okay, page that has alpha 0.025. At the top row, find number 5. At the side column, find number 4. Match these two reference number and you should get 9.3645. So 1 divided by 9.3645 is 0.1068. So that is the left hand side critical value. So once again, class, remember, even though it is a left hand side critical value, it remains positive. Okay, for this subtopic, okay, F distribution, it remains positive. Now this is the established rejection region and critical value. Okay, tengok balik, what is our test statistic? The test statistic here is 1.0808. So where is it? Okay, between 0.1 and 7.3. So maybe 1.0 is somewhere here, which means your F-test, your test statistics falls in the acceptance region. Again, ya Allah. We've been doing example that gives us a test statistic in the acceptance region, right? Kita apalah, tak kisah, it's okay. So we don't reject H now. Okay, class, when you have your test statistic, okay, for a two-tailed test, for a two-tailed test, anything lah, chapter 3.2 ke, whichever chapter, if it is a two-tailed test, and if your test statistics falls in the acceptance region for a two-tailed test, this is how you should write the notation. Okay, to show that your test statistics is in between. Okay, it is bigger than the left hand side critical value. It is smaller than the right hand side critical value. So remember, for a two-tailed test, hypothesis testing, if your test statistic falls in the acceptance region, you need to write step 4 like this. Okay, you need to show that the test statistic is in between the left hand side critical value and the right hand side critical value. Okay, so the decision here is to not reject H now. You also can write it like this. Since the F test falls in the acceptance region, then we don't reject H now. Such is also accepted. Okay, you can also write it like that. Okay, done for step 4. So for step 5, we need to recall what is your hypothesis statement. Okay, so what happened here? So you don't reject H null, which means the H naught statement is true. Okay, the H1 here needs to be rejected lah. This is correct. This is correct. Okay, don't reject H null, which means that the statement that says variance of human resource is equal to variance of research department is the one that we cannot reject in this hypothesis testing. Okay, so this is the correct statement. This is the true statement for the whole population. So what happened to our claim? So initially we claimed that the variances are different, but it turned out to say that this is the correct statement. So because of that, because of the decision is to support the statement that the variances are equal, so the claim that say that they are different needs to be rejected lah. Okay, so there is insufficient evidence to support the claim, or in other words, at alpha 0.05, there is enough evidence to reject the claim. Okay, we can't support it. We need to reject the claim. So this hypothesis testing, okay, the sample collected shows us that the population variance of human resource is equals to the population variance of research departments. So this is the solution for question A just now. Okay, is there any difference? So no lah, there is no difference because it is equal. Correct or not? Kan? We don't reject H now, kan? Yeah, so this is question A, class. And next is question B. Kenapa ada dua soalan? Tak apalah, kita tengok The director of the company has agreed to upgrade the computer processing time in research department if the mean research department is greater than the mean human resource. So the director say, okay, research department, I will upgrade your computer processor if your average time is greater than the human resource average time. So this is what the director say. Is there enough evidence to support the director's claim at 5% level of significance? So this question, class, is hypothesis testing concerning population mean. It is not concerning population variance, okay, because it has clearly mentioned, okay, it is about mean here. Right, so but why is it included in this subtopic? This subtopic is about ratio of variances, kan? So jom kita tengok kenapa So here you need to test whether is it true that research department has mean of processing time greater than human resource. So mu2 greater than mu1. So 2 here for research department, kan? 1 is for human resource. So this is your claim. Alright. So apa nama, yeah, actually you should actually bring over this to the left hand side, then only can you see the hypothesized mean difference, which is 0. Kan, so mu2 minus mu1 greater than 0, mu2 minus mu1 less than or equals to 0. So claim is at H1. So in step 2 you need to find the apa nama test statistic value, kan? So if you recall, well, of course this is the case of independent samples, kan? Independent samples. Human resource are different people, research are different people. So yeah, there are 2 different departments. So this is the case of independent samples. And if you recall, the subtopic for independent samples, there are 5 different formulas to choose from. Okay, if it is sigma square known, so there's only one formula. Sigma square unknown, you have 1, 2, 3, 4 different formulas. So let's take a look at our question just now. Which type is this? So obviously there are no population variances given in the question. So this is the case of sigma square 1 and sigma square 2 unknown. And then the sample sizes are less than 30. Okay, sample sizes are less than 30. So 30. So you will choose which one? Okay, sigma square unknown, sample size less than 30 is either this t-test or this t-test. This is also sample size less than 30, sigma square unknown. This is also sample size less than 30 sigma square unknown. So which one should you use, the third or the fifth formula? So you need to know the assumption kan. Okay, is it to assume that the population variances are different or population variances are equal? So we need one more information to choose the correct formula. So let's take a look at the question again. Mana tadi? Sini. Okay, so if you look at the question, they don't tell us what is the assumption. They didn't say assuming population variances equal ke assuming different. So they don't say. So how do you know whether it is equal or different? So you should refer to the result of your hypothesis testing in question A. Okay, what does the result just now? What is the conclusion just now? We concluded that there is no difference in the variability, which means that sigma square 1 is equals to sigma square 2. So even though we don't know the value of the sigma, but we can use this hypothesis testing result to assume that the population variances are equal. So by using this assumption, by using this result, okay, we will use that assumption to choose the correct formula. Okay, so that's why sometimes in the final exam, this is how we ask you lah. Okay, first we want you to find out whether it is different or whether it is equal, and then based on this result, you will use this result to choose the correct formula for the differences in population mean hypothesis testing. So this is what I need to show you lah. You can look at the solutions for this independent samples hypothesis testing, and I'm sure you will be able to understand it. It's just doing the same thing that we've been doing, all the 5 steps being repeated again and again. Okay class, so yeah, sometimes the question didn't give you the assumption for the independent samples, sigma square unknown. The question didn't give you whether assuming population variances equal or difference, because they actually want you to use the result from the previous questions. Okay, that's all class. That is all I need to explain to you in this video. You do need to try on some of the exercises, get used to this hypothesis testing, and please bear in mind, okay, the hypothesis testing that consists of 5 steps, this is called the traditional approach hypothesis testing. Okay, next week we're going to learn on 2 other methods of doing hypothesis testing. So this is traditional approach. Next week, we're going to learn on how to conduct hypothesis testing using confidence interval approach and also p-value approach. So look forward to it. Okay, I'll see you in our class this week, inshallah. Thank you so much for listening in, and bye-bye.